everyone. Today we're going to go through a sample scientific journal article. And as I talk about what things I'm noticing and the things to highlight in there, kind of is going to help you understand what kind of thinking you're going to do when you're actually looking through a paper. So it's not at all like other kinds of reading. Personally, I like to have a printed out paper. I write lots of notes on it, but I'm going to go through it as a PDF file for you, so it's easy to see from your screen. So bear with me. It may seem a little rambling and purposeless, but the idea is for you to kind of see my thinking as we go through this example paper. Plus, I think you'll be interested in finding out how you can use studying strategies to increase your exam scores in your biology class. The paper is titled, "To What Extent Do Study Habits Relate to Performance?" This is a little vague, so let's read the abstract and find out a little more about what this paper is about. So normally when you're doing a literature search, if there's a paper you think might be interesting, then you're going to go and find the abstract for it and read that. And that's really what's going to tell you whether it is interesting enough that you want to try and actually read the whole thing. The titles aren't necessarily enough for you to find out. All right, so student study sessions outside class are important learning opportunities in college courses. However, we often depend on students to study effectively without explicit instruction. In this study, we describe students' self-reported study habits and related those habits to their performance on exams. Notably, in these analyses, we controlled for potential confounds such as academic preparation, self-reported class absences, and self-reported total study time. First, we found that on average, students used approximately 4 active strategies to study, and that they spent about half of their study time using active strategies. In addition, both the number of active strategies and the proportion of their study time using active strategies positively predicted exam performance. Second, on average, students started studying 6 days before an exam, but how early a student started studying was not related to performance on interim, immediate, or cumulative delayed exams. Third, on average, students reported being distracted about 20% of their study time, and distraction while studying negatively predicted exam performance. These results add nuance to lab findings and help instructors prioritize study habits to target change. All right, so this paper is written by instructors who are studying how students study. All right, and you can see that in this last sentence here, they have a purpose to doing this, which is to try and help students learn better study habits so that they can do better in their classes, which is a nice thing to know that instructors are thinking about. All right, so I have in red, these are the parts of the paper that you really are the other ones you really need to read if you're just interested in finding out a little bit about the paper. So if there's vocabulary, you're not sure what it means in the abstract, often it will be explained if you go on into the introduction, right? So they are going to describe in the introduction what overall motivation or background is for doing this work, have other scientists already found, and what open question is still remaining. So we can find usually at the introduction some ideas about kind of the overall purpose, right? So they investigated the frequency with which students reported carrying out effortful or superficial study habits in a large introductory biology course. We examined the relationship between study habits and performance on exams. while controlling for prior academic preparation and total study time, right? So the first thing you might think is, well, how well students do in a class has got to partly depend on how much they know already, right? So they made sure they included that in this study so that they could factor it in. All right, so this theoretical framework. Now, this is a fairly long section, but it's going to describe and explain a lot of the vocabulary that they're using. So, what do we define as an effective study habit? And so this is the background work that they used to figure out exactly what they wanted to do in their study. So these are the parts that I've highlighted. And there's a lot here. So you want to just read this fairly quickly. If you were working in a similar field, you would want to read this much more carefully, right? But for the purposes of our class, we're just trying to, as kind of concerned citizens or interested people, not necessarily scientists, how we can read a paper and get useful information out of it, even if we don't understand all the details. Right, so we want to zoom in on the parts of the paper that are going to give us that information. And this is a particularly well-written paper with a very clear organizational structure to make this fairly easy and straightforward for you. So at the end of that first little section, they have a summary, available research. So the background says active, effortful study strategies are more effective than passive ones. Cramming is less effective than distributing study over time. So cramming is a term that's used for studying really hard at the last minute, pulling an all-nighter, memorizing everything, hoping for the best. Focus study is more effective than distracted study. Whether students choose to use these more effective practices during their independent study time is a separate question. It's a little, subtle here, but that's what they're focusing on in this paper. They want to know what strategies are students in their classes actually using. So they talk a little bit more about literature that supports that. And the really nice thing about this paper, this journal, is that they call out hypotheses that they're going to test. They aren't just saying, oh, some vague general thing. They have these very specific statements that make predictions, right? They're not written in symbols like our hypotheses are when we're actually doing the statistical test. And they're actually going to do more than one statistical test to try and answer or test each of these hypotheses. Right. So their first one is students who use more active study strategies or who devoted more of their study time to active strategies would perform higher on their exams than those who use fewer. Right. So this is a one-tailed or a two-tailed hypothesis test. It's a one-tailed. They want to see if exam scores are higher when studies use active study strategies. Second, that students would have different study times, but those with cramming their study time together would not perform as well as students who spaced out their learning. So there is a demonstrated learning strategy, which is spaced learning, that is well documented to form better long-term memories, which is you study a topic and then you wait a week and then you study it again, right? And then you wait a week and you study it again. Now you have to plan that ahead. Most of us aren't really that good at not procrastinating. So that's what they were looking to see, as if students who were doing the spacing thing were doing better. And finally, students would report at least some distraction during their studying, but those who reported being distracted for a smaller percent of their study time would score higher on exams. All right, so this is a prediction that there's an increase in distraction. It's going to be a decrease in score. And so an inverse or negative relationship between those two variables. Now, for us, the interested observer, for the most part, we can skip the methods. If you're interested in figuring out exactly how they did something, and you can dive in here, but you don't really need to look at it when you're first scanning through the paper. It's a lot of details that are important to other scientists, so the peer reviewers would want to know how they did the work in enough detail that they can tell whether they did it correctly, whether they followed protocols that are uh, unbiased, that they controlled for the things that they needed to, everything from what software they used to do the analysis to exactly how they measured these variables. So, for example, they did surveys of their students in order to find out this information. All right, so that's if you're interested and you want to look in here in the methods. So, but typically you can skip it. Same thing with the results. That might seem counterintuitive, but they're going to go into a lot of gory detail here. Now, the one thing that you might want to do as you're first scanning this article is to look at the tables and figures. So tables are going to be like words and numbers that are in this format, and there's some interesting things in this table. I've put some summaries in here. So this table lists study strategies and assigns them to active or passive types. All right, there's a lot more stuff in here, sample sizes and percents, and we don't necessarily need to worry about that. Maybe you don't know what they mean by synthesized notes. Well, it means paraphrased or outlined class notes. And that's different. That's an active strategy that's different from rewrote notes, which is just rewriting the notes word for word, and that's considered a passive strategy. So a little bit more definition of terms here is useful. I did some highlighting in this section, but you might not want to, we'll come back to that after we've read the discussion. All right, we've got another table here, and this one has results. Notice these little stars, and the information about the table that's below it here is showing you that there's 1 star if p is less than 0.05, 2 stars if p is less than 0.01, and 3 stars if p is less than 0.001. So the smaller the p-value, the more stars. And we usually read this as these ones with 3 stars, that this result was highly significant. All right, so you had a really small p-value there. Now, we didn't talk about it in class, but for regression, the hypothesis you're testing is that the slope of the regression line is, the null hypothesis is that the slope is equal to 0. That means there's no relationship between the two variables. You don't know anything about one from learning the other. All right, so that we see that the prior preparation that students have, their score on the ACT and their score on a bio pretest, those things did have a significant effect on how well students did on exams 1 and 2. Also, the number of classes that they missed. Now that has a negative number. That means it is an inverse association. So the more missed days, the worse scores on exams. I expect that to be true. And the same thing, total exam study hours, right? They want to control that in how they do the rest of the analyses. They don't want to compare students who did 1 hour of active studying with 5 hours or 20 hours of active studying. So they needed to know how many study hours total the student did. Now, my little summary of this table is that this table shows the fit of the base model to the data, and prior knowledge, classes missed, and total time studying all have a significant effect and explain 32.7% of variation in exam 1 score and 21.9% of variation in exam 2 score. So notice these R squareds here, and this is a multivariate model, but R squared is interpreted exactly the same way. So if we combine all these variables together, then we've explained 0.327 of the variation in exam scores, right? That's a pretty small R-squared in general. But when these authors talk about it, they say, oh, this is a good amount of explanatory power. So perhaps in psychology research, these smaller R-squareds are more normal. If I was an ecologist, I wouldn't be very happy about that. Well, I am an ecologist, and I'm not very happy about it. All right, so we don't have to necessarily scrutinize this information. I just want to give you my summaries as we're going through. And that's something that I encourage you to do when you're looking at the figures and tables, is try and do a summary in your own words. And that is going to make sure that you're looking carefully at what's in the table and making sure that you understand it. Right now, this is a big table. This is one of the more important results that's being shown here. And this is showing for each of these individual strategies by itself, and it reviews what type it is, active or passive, what the little b is, and that's the slope. So the beta and the little b are both measures of slope. And it gives the standard error, and then it gives this delta R squared. Now, the delta R squared is the change in overall fit of the model when we take out each of these strategies one at a time. So the ones that have bigger values for this delta R squared means that they change the R squared more when we take them out versus putting them in. There's this baseball statistic that's like this. There's a team wins when they have a player in versus when they don't have that player in, and it measures the power that that player has contributing to the lineup. So when we look at these variables, these slopes, the larger positive values are going to be, and you actually want to look at these numbers. Like, so there's negative numbers in here, there's positive numbers. All right, so positive numbers are going to be improving, factors that improve scores. And the bigger the positive number, the more improvement. Right, so we see that these active, not all the actives, but most of the actives have the biggest numbers. Not all of them, some of them. All right, so completed problem sets, self-quizzed, explained concepts, those are the biggest. Let's see, there's one, attended review sessions, help sessions, or office hours. Check that out. And some of them are negative, right? These passive strategies, actually, if that's all you do, is going to you're going to have lower exam scores than if you did these active strategies. Right, so not all the active strategies had the highest effect, and all of these big numbers were significant. Some of these negative numbers are these small ones. They're not even a significant effect. All right, if you look at this table a little more carefully, there are some different patterns between exam 1 and exam 2. We're not that concerned with those. And so my summary of this table is the largest effects and most significantly higher scoring students used active study types. Passive strategies are associated with lower test scores. All right, so there's a lot of information in here, but you can sum it up in a sentence or two. Somewhere in the paper, the authors also have written their summary of what those results are. Now, when we start to look at the graphs, these graphs have a quantitative x-axis. They have number of students, and even though they have these spaces in between the bars, these graphs are histograms. They shouldn't have spaces between the bars, but maybe they wanted to make it easier to read these numbers. They shouldn't have these ranges. They should just have the right side end. And having these percents on the top of the bars is a little redundant. Anyway, so we can see these patterns. We have most students are kind of in the middle of the distribution, using active study strategies. So these graphs, and so the one on the left is exam 1, and the one on the right is exam 2. So something I noticed is that in general, students have shifted a little bit towards more active studying strategies across the semester. So probably learned by trial and error which things work. So we do see some change in student behavior from exam 1 to exam 2, but the general patterns still hold. All right. So these other figures also are histograms, and we can see, well, this one's on an ordinal variable. There's not that big a range, number of strategies. So these are really bar charts more than they are histograms because we've only got 0, 1, 2, 3, 4, 5, 6. All right, so days in advance, exam 2 studying began. All right, so most students began from 0 to 6 days, and then we have a few students that studied almost a month. But this is a really right skewed graph. We have a few individuals with much longer times. All right, number of days studied in the week before the exam. Most students studied quite a bit in the week before the exam. And this bar on this graph just makes me chuckle every time I see it. This is the week before the exam, but they've counted 8 days. So I always think of the Beatles song, 8 days a week here. And it's just a little weird, but this is if you're really carefully scrutinizing the graphs and the tables and everything, then hopefully this is something that you noticed, and you, the thinking scientist, is saying to yourself, wait a sec, a week has 7 days. And so when we talk about critical thinking, a lot of what we're doing is we're just noticing things. Okay. Does it really matter in the results if they counted 8 days? All right, so maybe they should have said in the 8 days before exam 2. Right, so they had a lot of students that studied 8 days a week before the second exam, hoping to get a good grade. All right, so the next, this is again a really nice feature in this paper. And again, this red highlighted section, this discussion, this first paragraph of the discussion actually summarizes all their results. So in the results section, you're just going to see really specific descriptions of what they saw in their results. How many students did this? What percent of students were that? What's the p-value? What's R squared? They aren't going to try and interpret or explain to you what that means, right? That is saved for the discussion. All right, so they have a really nice, clean, tight study design here. They've written the paper really clearly in this nice outline, so they can go back to their introduction and see what they need to talk about in their discussion. So they have this overall summary. What are their results? We found students who spent more time on effortful active study strategies and used a greater number of active strategies had higher scores for exams. Right, so they actually used 2 different response variables to answer that same question because they wanted to get at it in a couple different ways. Yet, neither students who started studying earlier nor those who studied over more sessions scored differently than students who started later or studied over fewer sessions. Right, so they didn't support their prediction. They thought students who were going to do the spaced learning thing were going to score better. Right, no, they're talking about biology students. What we are awesome at is memorizing a whole bunch of stuff the night before the exam. Now, when you get to your harder classes, this may not be true. All right, so they had a negative result here. They thought they'd see something and they didn't. All right, but you just report it. It's not like it was a mistake, right? You learned something useful. So even if you didn't support your hypothesis about how something is gonna change, you still just report on it. Certainly don't falsify your data to make it look like this thing really happened. All right. Additionally, students who were more distracted while studying tended to perform worse than students who were less distracted. In other words, both the degree to which students employed desirably difficult strategies while studying and their level of focus when doing so were important for performance. All right, now they're going to go into more detail in this discussion now, talking about each of the hypotheses separately. They're going to bring in more literature. They're going to say, well, our results are similar to these people's, but they're different from this other survey, and this is why we think so. All right, they're also going to talk about why maybe did we find the things that we did. All right, so the study timing, they didn't find the things they thought they were going to. They're going to talk about why they didn't. And in this case, they think, well, maybe they didn't really test they didn't really, the way that they sampled or got their information didn't really test the hypothesis very well. So that's an example of what that might look like. All right. So the shortest discussion about the hypotheses is this one about distraction. So you might want to read this one in more detail. Notice that they're citing more literature here, and also talk about whether the things in their study might have made them underestimate or overestimate, right? So that's a really common way that we talk about, what might have gone wrong with how our and we may not realize that until after we've done it, right? So you don't have to do it all over again just because you notice some things that could be done better. All right, now this last little section is on implications for instruction. Their purpose was to really, their long-term goal was to learn how they can leverage results to help students change their habit. All right, so here are their recommendations to encourage students to use more active study strategies, maybe give you credit for them or to make sure quizzes are available to you. Maybe to model or demonstrate self-quizzing in class so that students know how to do it. Maybe you were not doing these strategies because you don't know how, you never thought about it, right? And how would you know if nobody ever taught you? And finally, encourage students to stay focused during studying, maybe providing study sessions. But we all have had the experience where we've told somebody what's good for them and then you just go and don't do it. So I think these instructors were maybe feeling a little frustrated with seeing how important focused study, non-distracted study was, and then actually trying to get students to do it. So I actually want you to think about your students. You know how you study, you know how it works. I'd like you to think about what they found in this study and how it relates to your own personal experience. And also, do you think these strategies for instructors could help, would they really help students learn the results from this study and in order to, so you see how sneaky I am about having you actually read this paper. Because you're actually learning something. This isn't just an exercise where you're reading about, I don't know, coral reefs in Hawaii, and it may be interesting and kind of cool, but it doesn't really impact your personal life, right? So that's one of my strategies for making you think about your learning, which is a research demonstrated strategy to help you better learn. All right, now they also have this last section, limitations and future directions. Absolutely everyone is going to write at the end of their paper that, we raised these new questions. Every question you answer, you raise 3 new ones, right? And so you want to say that in your paper, you want to be able to get more funding for your research in the future. So nobody's ever going to say, we have sufficiently answered this question. We don't have any follow-up experiments that we want to do. But usually these can be pretty interesting to read. And I also want to know if you have additional follow-up suggestions for studies that you thought of when you were reading this. You were thinking to yourself, that's not a good way of measuring that. As a student, I do X, Y, and Z. This is the question you really should be asking. All right, so I would love it if you put any of your thoughts about instruction and in this little follow-up section into the class chat for this week, so we can maybe have a little further discussion in there. Finally, the references are a place where if you're interested in this kind of research, then you might want to follow up, read some of these papers. So these are really important, and they're cited throughout the paper so that as you're looking at, why is the scientist saying in prior research we've already learned X, right? Then that will be cited in a paper, and that paper will be found here in the references. All right, so in general, as you're reading the paper, just be, asking questions, and you're going to have to flip through it, right? So we looked at, I was going to go back and show you. So after we looked at all of the results, scrolling, close your eyes if this is making you dizzy. Going back and looking at a little bit more of the results on things that interested you might be something you want to do. And so there's just a couple things I highlighted that I thought were interesting. We found that students who reported being distracted 10% more than other students scored about 1% lower on exams 1 and 2. Well, 1%, that doesn't seem like that much. But there's a big difference in students who were distracted a lot versus much less, right? So looking at sort of the actual effect size, how big a difference was there? So notice that the authors report the mean and the standard deviation, just like I've been telling you all semester. And they're also reporting their p-value and talking about, if their hypothesis was supported or if it was contradicted. So one of the most interesting results that I thought for the whole paper was this little point. Students who spent all their study time on active strategies scored 5.5% higher and 10% higher on exams 1 and 2 respectively. All right, so 5.5% higher on exam 1 and 10% higher on exam 2 than students who spent none of their study time on active strategies. All right, so this is a whole grade higher. You would go from an 80% to a 90%. You switch to active strategies, right? In the grand scheme of things, it's not going to take you from a 50% to a 90%. But if you're frustrated, you feel like you're always stuck and, you just can't quite get to an A, maybe looking at your study strategies is the thing that can push you over that hump. Okay. All right, so there's a lot of interesting stuff in this paper. If you have other questions about it, then go ahead and put those in the class chat or send me a comment question by email, and use the kinds of reading and thinking strategies that I demonstrated for you in this example when you are working on your actual assignment for this week, which is a whole different paper. It's actually a little easier to read, so you should do great with that.